You think you know volcanoes? Lava? Ash clouds? Maybe Pompeii rings a bell, but nobody talks about what happens when the mountain doesn't just erupt, it collapses. When the wave hits before you can run. When the ash falls and the harvest dies and 20,000 people starve in the snow. These 7 eruptions didn't just kill in the moment. They rewrote coastlines, erased civilizations, triggered famines across continents. Each one left a body count that still makes volcanologists go quiet when they pull the numbers. 7 cases. 7 mountains. 7 moments when the earth opened and everything changed. If you value documented volcanic history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. Also, this script is researched and factual. Using sources from the Global Volcanism Program Volcanoes of the World Database, published September 30th, 2025, by the Smithsonian Institution, and the Volcanic Fatalities Database Analysis published in the Journal of Applied Volcanology, September 20th, 2017, analyzing 278,368 fatalities across 635 records from 1500 AD to 2017. These aren't Wikipedia summaries. These are peer-reviewed volcanic death records with distance data, cause classifications, and excavation reports that most documentary crews never touch. Now back to the information. Number 1, Mount Tambora, April 10th, 1815, Sumbawa Island, Indonesia. The mountain stood 4,300 meters. Locals called it sacred. Dutch merchants logged tremors for 3 years, but nobody evacuated. April 5th, the explosions start. Ash falls on Java, 250 kilometers east. Ships report cannon fire sounds, but the captains keep sailing. On April 10th at 7 p.m., Tambora doesn't erupt, it detonates. The blast throws 40 cubic kilometers of rock 33 kilometers into the stratosphere. That's 6 times Krakatoa. The volcanic explosivity index hits 7. The sound travels 2,600 kilometers to Sumatra. The column collapses into pyroclastic flows that hit the coast at 200 kilometers per hour. On Sumbawa, 3 villages vanish in minutes. Tambora, Sanggar, Pekat. 71,000 people die in the flows and falling debris. But that's just the count from the mountain. The ash buries crops across the Indonesian archipelago. 120 million tons of sulfur dioxide hits the upper atmosphere. It forms sulfate aerosols that circle the globe in weeks. By 1816, temperatures drop 0.4 to 0.7 degrees Celsius worldwide. Europe calls it the year without a summer. In Switzerland, grain prices quadruple between 1815 and 1817. Typhus spreads in the food lines. The canton of Bern reports grain at 320% of pre-eruption prices by summer 1817. Farmers can't pay, families starve in the streets. Tuberculosis and typhus spread through the crowded poorhouses. In China, summer snowfalls in Yunnan province, rice paddies freeze. Flooding destroys the autumn harvest along the Yangtze. The water levels rise 6 meters above normal in some districts. Historians count the famine deaths in China alone at 100,000. Add Ireland, Germany, the northeastern United States. In Connecticut, the temperature hits negative 7 degrees Celsius in June. Snow falls. Crops die in the ground. The harvest fails completely. Corn prices triple. In New England, 1816 becomes known as the poverty year. Families abandon farms and move west looking for better land. In Germany, food riots break out in Stuttgart, Tübingen, and other cities. Soldiers fire on crowds demanding bread. In France, still recovering from the Napoleonic Wars and the failed harvest of 1811, the Tambora cooling delivers another blow. Grain reserves deplete. Beggars fill the roads. The government struggles to import food. Social tension climbs. Some historians argue the food crisis from Tambora adds fuel to the revolutionary sentiment that would explode again in 1830 and 1848. In Ireland, the potato crop fails. Famine conditions preview the great hunger that would devastate the island 3 decades later. Across the northern hemisphere, the pattern repeats. Cold, wet, crop failure, hunger, disease. Some estimates put the total global death toll from Tambora triggered starvation at over 1 million people within 3 years. Conservative counts say 300,000. Either way, it's more than any single battle of the Napoleonic Wars. And it all traces back to one mountain in Indonesia that nobody outside the region had heard of before it exploded. Mary Shelley writes Frankenstein during that cold summer at Lake Geneva, trapped indoors by the gloom. Lord Byron pens darkness, but most people aren't writing. They're dying. The volcano summit collapses into a caldera 6 kilometers wide, 2 kilometers deep. When Dutch officials reach Sumbawa in 1817, they find entire districts gone. No survivors. Just ash layers 2 meters thick over what used to be fields. Tambora remains the deadliest eruption in recorded history by direct and indirect toll. The mountain lost 1,400 meters of elevation. You can visit the caldera now. It's quiet. The ash has weathered into farmland again, but the bones are still down there under Sangor village site. They stopped counting at 71,000. Number 2, Mount Pelée, May 8, 1902. Martinique, West Indies. St. Pierre sits on the coast. 7 kilometers south of Pelée, 30,000 people. They call it the Paris of the Caribbean. Sugar, rum, a bustling port. The mountain smokes through April. Ash falls on the city May 3rd. A mudflow buries a sugar mill May 5th, killing 150. The government sends a commission. They report no immediate danger. Governor Louis Moutet stays, his wife stays. They assure the population. The volcano has erupted before in 1792 and 1851. Small events. Pelée always settles May 8th, 8:02 a.m. The telegraph operator in St. Pierre taps out his morning report. The line goes dead mid-transmission. The northern flank of Pelée rips open. A pyroclastic surge, superheated gas, ash, and rock fragments, shoots horizontally at 160 kilometers per hour. Temperature 400 degrees Celsius. It reaches St. Pierre in 60 seconds. The surge is a nuée ardente, a glowing cloud. The term didn't exist before this. French geologist Alfred Lacroix invents it after examining the wreckage. The cloud hits the city like a horizontal explosion. Buildings shatter. Walls blow outward. Stone structures 3 feet thick crumble. Iron beams twist like wire. Church bells melt. The rum distilleries explode, fueling a firestorm. In 2 minutes, 28,000 people die. Burned, crushed, asphyxiated. The heat flash fries everyone in the blast radius. Bodies are found in natural positions, sitting at breakfast tables, lying in beds, but carbonized. The pyroclastic surge moved so fast that people died before they could react. No time to run, no time to scream. One witness on a ship offshore describes the cloud as solid black shot through with lightning, moving like a tidal wave over the land. The only survivor in the city proper is Ludger Silberis, a prisoner in an underground cell with one small window. He lives with severe burns covering his body. He later joins the Barnum and Bailey circus, displaying his scars as the prisoner of St. Pierre. A few dozen people at the margins of the cloud survive with injuries. A shoemaker on the southern edge of town lives but loses his entire family. A woman on the northern outskirts survives but goes blind from the heat. The city is gone. Ships in the harbor burn and sink. The Roraima, a steamship, catches fire. Some crew survive and describe the black cloud rushing down. One witness says it looks solid, like a wall. On May 20th, a second pyroclastic surge destroys the ruins. 2,000 rescuers and engineers die. August 30th, another surge strikes Morne Rouge to the northeast. 800 dead there, 250 in Ajupa-Bouillon, 25 in Basse Pointe. The eruption kills over 30,000 total. It's the deadliest volcanic disaster of the 20th century. Pelée changes volcanology. Before this, scientists thought lava flows were the main threat. After Lacroix publishes his 1804 report, over 600 pages documenting the blast, the deposits, the body positions, the thermal damage, pyroclastic flows become the focus. This type of eruption is now called Peléan. The summit grows a lava spine 300 meters tall after the eruption. They call it Pelé's Tower. It grows 15 meters a day until it collapses in 1903. U.S. Consul Thomas Prentice dies with his family in St. Pierre. He thought he'd have time to evacuate. He didn't. His last dispatch reached Washington hours before the surge hit. Number 3, Nevado del Ruiz, November 13th, 1985. Colombia, South America. The volcano stands 5,389 meters in the Andes. Glaciers cover the summit. It's called Nevado because of the snow. The town of Armero sits 46 kilometers northeast. Elevation 300 meters in a river valley. 29,000 people live there. The volcano rumbles for a year. Scientists warn. In October 1985, geologists from India Ominas submit a report. It predicts a 100% probability of lahars if the volcano erupts. They map the hazard zones. Armero sits in the red zone. 10 copies of the report circulate. Evacuation plans stall. Local officials hesitate. It's expensive. The public doubts. Ruiz erupted in 1845, killing 1,000. That was 140 years ago. November 13th, 9:09 p.m. A small eruption melts part of the summit glacier. Not much magma. Dacitic tephra shoots 30 kilometers up. But the heat melts 10% of the ice. 200 million cubic meters of ice becomes meltwater. Meltwater mixes with ash and rock. Lahars form and race down the river valleys at 60 kilometers per hour. The largest lahar follows the Lagunillas River straight toward Armero. The volume is 40 million cubic meters of mud, rock, boulders, trees, debris. It's the consistency of wet concrete. The town is in darkness. A storm masks the eruption sounds. Thunder and rain drown out the volcanic rumble. At 9:45 p.m., civil defense officials in Ibagué try to radio Armero. The line is busy. They hear the mayor on a ham radio telling someone that he doesn't think there's much danger. At 11:25 p.m. ice, the lahar hits a wall of mud, rock, trees, and debris 30 meters high in places. The initial surge is faster, hitting at 100 kilometers per hour at the canyon mouth before spreading and slowing across the flat valley floor. Armero vanishes in minutes. The mud buries 3/4 of the town to depths of 2 to 5 meters. 23,000 people die. Most drown or suffocate in the thick slurry. The lahar destroys 5,000 homes. It wipes out 50 schools, 2 hospitals, roads, bridges, power lines, aqueducts, telephone exchanges. The infrastructure is obliterated. The lahar travels 100 kilometers from the summit in 2 hours. Survivors describe hearing a roar like thunder, then the lights go out, then cold mud filling the streets at chest height within seconds. Those who climb to roofs survive, if the buildings don't collapse. Most buildings collapse. The mud pressure is immense. One survivor, a priest, describes clinging to a doorframe as his church filled with mud up to the ceiling. He swam through a window. Behind him, 150 people drown in the church on the west flank. Another lahar buries neighborhoods in Chinchina. 1,000 die there. Total death toll 25,000. It's the second deadliest volcanic disaster of the 20th century after Paley. It's the deadliest lahar in recorded history. A girl named Omaira Sanchez becomes the face of the disaster. She's 13, trapped in debris for 60 hours. A photographer captures her image. She dies before rescuers can free her. The photo circulates worldwide. Rescue efforts are chaotic. Roads washed out. No helicopters can land in the mud. The United States sends aid. The Colombian government creates INGE Ominas, the National Geological Service, in 1989. Decree 919 establishes the National System for Disaster Prevention and Response. The law shifts focus from response to prevention. Monitoring stations go up on every active volcano. In 2007, Nevado del Huila erupts. 4,000 people evacuate from Belalcazar. The lahar hits an hour later. 0 deaths. The system works, but Armero is gone. The ruins are preserved as a memorial. You can still see the mud field. Pieces of buildings poke through. The death toll could have been 0 if the report had been acted on. Number 4, Krakatoa, August 27th, 1883. Sunda Strait, Indonesia. The island sits between Java and Sumatra. 9 kilometers long, 5 wide. 3 volcanic cones, Rakata, Danan, Perboy Watan. On May 20th, a German warship reports a smoke column 11 kilometers high. Explosions continue through the summer. Locals watch from the coast like it's entertainment. Sightseeing boats take tourists to view the activity. Pumice floats form in the Sunda Strait, meters thick in places. Ships navigate around them. August 26th at 1 p.m., the eruptions intensify. Pumice and ash rain on ships. Captains report darkness at midday. At 5:07 p.m., a massive blast. At 10:02 a.m., August 27th, the mountain explodes. The northern 2/3 of Krakatoa collapses into the sea. The blast ejects 30 cubic kilometers of rock. The sound is heard 4,800 kilometers away on Rodriguez Island near Mauritius. People there report it sounded like distant artillery. In Perth, Australia, 3,200 kilometers away, police receive reports of gunfire at sea. They send boats to investigate. Nothing. In the Philippines, 2,400 kilometers northeast, the sound is described as thunder. In Alice Springs, Australia, 3,600 kilometers away, people report hearing it clearly. It's the loudest sound in recorded history. The pressure wave circles the globe 7 times, confirmed by barograph readings in weather stations worldwide. In London, barometers spike. In Washington, D.C., the instruments record the pressure pulse. In Bombay, the readings show the wave passing through. The energy released is equivalent to 200 megatons of TNT. That's 4 times the largest nuclear bomb ever tested, the Soviet Tsar Bomba. The column of ash and gas reaches 50 kilometers into the stratosphere. The explosion creates pyroclastic flows that travel across the sea surface 80 kilometers to southern Sumatra. 4,500 people burn to death in the flows, but the main killer is the tsunami. When the mountain collapses, it displaces massive volumes of seawater. The first wave is 120 feet, 37 meters, high at the source. It strikes the coasts of Java and Sumatra at 100 kilometers per hour. 165 villages and towns wash away. In Batavia, now Jakarta, 2,000 Chinese immigrants drown in the low-lying harbor district. Serang is entirely submerged. Nearly everyone dies. In Merak, the wave is 40 meters high. Ships are hurled inland. A steamship, the Brau, ends up 3 kilometers from the coast, stranded on a hill. The official Dutch East Indies count is 36,417 dead. Most die in the tsunamis. The waves travel the Indian Ocean. They reach Cape Town, South Africa. In the Pacific, Honolulu records a 0.24 meter wave 17 hours after the eruption. Ash drifts into the upper atmosphere. Sunsets turn vivid red and orange globally for months. Edvard Munch paints The Scream in 1893, and some art historians link the blood-red sky to Krakatoa ash still circulating. Temperatures drop 0.5 degrees Celsius globally. They don't return to normal until 1888. A new island, Anak Krakatau, child of Krakatoa, rises from the caldera in 1927. It grows steadily. In December 2018, part of Anak Krakatau collapses during an eruption. The landslide triggers another tsunami. 437 people die along the Sunda Strait coasts. Same location, same mechanism, different century. If you value documented volcanic history and real numbers, drop that subscribe. Also comment where you're watching from. This information is based on the NOAA National Centers for Environmental Information Significant Volcanic Eruptions database, updated October 4th, 2025, which documents over 600 eruptions from 4360 BC to present time. And the Significant Tsunami Events database tracking every wave over 0.1 meters since 1700. These databases cross-reference death tolls with coastal tide gauge records, ships logs, and colonial administrative documents. Now back to the eruptions. Number 5, Unzen. May 21st, 1792. Kyushu, Japan. Mount Unzen is a volcanic complex on the Shimabara Peninsula, Nagasaki Prefecture. 4 main domes, Kinugasa, Fugen, Kusanbu, and Mayuyama. Mayuyama is 4,000 years old, a lava dome that hasn't erupted in recorded history. But in 1791, earthquake swarms start on Unzen's western flank. They migrate toward Fugen. In February 1792, Fugen erupts. Lava flows for 2 months. The earthquakes intensify, shifting closer to Shimabara City. The city sits at the base of Mayuyama on the coast of Ariake Bay. Population around 10,000. May 21st, night. 2 large earthquakes hit, magnitude 6.4. The southern flank of Mayuyama collapses. 340 million cubic meters of rock, soil, and old lava slide down in seconds. The landslide is 400 meters deep at its maximum. It moves at over 100 kilometers per hour initially. The debris avalanche is massive, one of the largest historical landslides. The landslide sweeps through Shimabara. 5,000 people die instantly, crushed or buried under tens of meters of debris. Houses, temples, rice fields disappear. The slide path is 2 kilometers wide. The debris enters Ariake Bay traveling at 50 to 70 kilometers per hour. The displacement creates a mega tsunami. The initial wave is 100 meters tall at the source where the landslide hits the water. The wave energy propagates outward in all directions. It crosses the bay at hundreds of kilometers per hour. In deep water, tsunami speed equals the square root of gravity times depth. Ariake Bay averages 20 meters deep. The wave moves at 50 kilometers per hour across most of the bay, faster in deeper channels. It strikes Higo province, now Kumamoto Prefecture, on the opposite shore, 20 kilometers away. The wave reaches there in less than 30 minutes. 5,000 people die there in the wave. Coastal villages are swept away entirely. In Higo, the wave inundation extends up to 3 kilometers inland in low-lying areas. Fields are salted. Wells are contaminated. The tsunami rebounds. It crashes back into Shimabara. Another 5,000 die in the return wave. Some people who survived the landslide die in the tsunami rebound. Total death toll 15,000. Out of an estimated total regional population of 50,000, 30% die. It's Japan's deadliest volcanic disaster. The wave height at Osaki Bana Point in Futsu reaches 57 meters due to seafloor topography, focusing the energy. Coral heads are ripped from the seafloor and deposited on land. One coral block weighing an estimated 20 tons is found 500 meters inland. The landslide creates 99 small islands in the bay, Tsukumojima. They're still there. A pond forms in Shimabara where the landslide crater filled with groundwater, Lake Shirachi. It was originally 1 kilometer by 400 meters. Drainage reduces it to 200 by 70 meters. After 1792, Unzen stays dormant for 198 years. In 1990, it erupts again. A lava dome grows at Fugen. Pyroclastic flows start in May 1991. On June 3rd, a flow kills 43 people, including volcanologists Katia and Maurice Kraft and Harry Glicken. They were documenting the dome growth. The flow traveled 4.5 kilometers, but compared to 1792, the 1990s eruption is minor. Modern monitoring saves thousands. The 1792 megatsunami remains one of the largest landslide-triggered waves in history. Only Lituya Bay in Alaska in 1958 was taller, 524 meters, but in a remote fjord with 5 deaths. Number 6, Laki. June 8, 1783 to February 1784. Iceland. Laki is a single mountain. It's a 25-kilometer fissure system with 130 vents. It connects to Grimsvötn volcano. On June 8th, the ground splits. Phreatomagmatic explosions first, groundwater meeting magma, then 8 months of continuous eruption, 10 pulses of activity. Each starts explosive, then shifts to lava fountains. 14 cubic kilometers of basalt pours out over 2,500 square kilometers. The largest lava flood since Iceland was settled in 870 AD. But the lava doesn't kill people directly. The gases do. 8 million tons of fluorine, 120 million tons of sulfur dioxide, that's 80 times Mount St. Helens, 3 times the annual industrial sulfur output of Europe in 2006, but delivered to the stratosphere in months. The sulfur dioxide forms a thick haze. It spreads across Iceland in days, across Europe in weeks. The haze reaches Prague June 17th, Berlin June 18th, Paris June 20th. In Iceland, the fluorine poisons the grass, livestock eat it. Dental fluorosis and skeletal fluorosis set in. 80% of Icelandic sheep die, but 190,000 head. 50% of cattle, 11,500 head. 50% of horses, 28,000 head. The livestock deaths trigger famine. The haze hardships, Icelanders call it, Motohardinden. The population drops from 49,609 in 1783 to 40,381 in 1786. That's 9,000 excess deaths. 20% of the population. Most die in 1784 and 1785. Starvation, contagious disease. A smallpox epidemic in 1785 kills another 1,500, but that's separate. The core famine toll is 8,000. The haze affects Europe. The summer of 1783 is the hottest on record. A high-pressure zone over Iceland pushes winds southeast, but by winter, the sulfate aerosols cool the northern hemisphere. The winter of 1783 to 84 is brutal. Gilbert White, a naturalist in Selborne, England, records 28 days of continuous frost. 8,000 excess deaths in the UK from cold. In France, the harvest fails in 1785. Rural workers go hungry. Bread riots. Some historians link Laki to economic conditions that fed the French Revolution in 1789. That's speculative. But the crop failures are real. In Japan, the Great Tenmei famine from 1782 to 88 kills 92,000. Mount Asama erupts in Japan in 1783, adding to the cooling. In China, drought and cold damage crops. The global death toll from Laki-induced cooling is hard to pin down. Tens of thousands, maybe more, across Europe, Asia, and North America. Benjamin Franklin, in Paris in 1784, writes about the constant dry fog. He speculates it's volcanic. He's right. But nobody knows about Laki yet. The connection isn't confirmed until the 20th century. Iceland loses 1/5 of its population. That's proportionally worse than any other eruption in history. The fissure system is still there. You can hike it. The lava field looks fresh. Moss covers it, but it's still rough. Laki and Grimsvötn are monitored now. If it erupts again at the same scale, the global effects would be worse. More people, tighter supply chains. Aviation shuts down for months. The ash alone grounds flights. But the main threat is the sulfur dioxide. It forms sulfuric acid in the atmosphere. Crops fail. Supply chains collapse. Laki is a reminder that low explosivity, long-duration eruptions can kill more people than big blasts. Number 7, Santorini, circa 1550 BC, Aegean Sea. The island of Thera, now Santorini, sits in the southern Aegean. Around 1600 BC, it's a thriving Minoan settlement. The town of Akrotiri has multi-story buildings, frescoes, advanced plumbing. It's a trade hub. The island is the rim of an older caldera. A new volcano grows in the center. Around 1550 BC, the volcano erupts. The date is debated. Radiocarbon says 1527 to 1550 BC using the INT-Cal 20 calibration curve. Archaeological correlations with Egyptian New Kingdom chronology suggest 1550 to 1480. BC. Tree ring data from Juniper in Turkey shows calcium depletion around 1560 BC, possibly from the eruption. Let's use circa 1550 BC as a working date until the debate settles. The eruption is volcanic explosivity index 7. It ejects 30 to 40 cubic kilometers of magma. That's one of the largest eruptions in the last 10,000 years. The eruption has multiple phases. First, Tefra falls on Akrotiri. The residents evacuate. No bodies found at the site. They had weeks of warning from precursor earthquakes and small ash falls. Then, the main eruption. Pyroclastic flows sweep the island. The volcano column collapses into the sea. That generates tsunamis. Deposits of broken building stones, marine shells, and Santorini ash are found on Crete at Palikastro. The tsunami deposit sits 35 meters above sea level. The wave was at least that high when it hit. Simulations suggest waves 10 to 35 meters striking northern Crete. The Minoan fleet, based at coastal towns, is destroyed. Ships are the backbone of Minoan trade power. Losing the fleet cripples the economy. The ash blankets eastern Crete, not thick enough to bury fields permanently, but enough to damage crops for a season or two. The sulfur dioxide in the stratosphere cools the climate. Summers turn cold and wet for years. Harvests fail. The Minoan civilization, centered at Knossos on Crete, declines rapidly after the eruption. Within 50 years, the palaces are abandoned or destroyed. Some archaeologists attribute the decline to the eruption. Others say it's coincidence, that internal political collapse or invasions were already underway, but the timing is tight. The eruption happens late in late Minoan IA. The palaces fall early in late Minoan IB. The connection is plausible. The death toll is unknown. No direct count exists. The island of Thera is evacuated so few die there, but across the Aegean, on Crete, the Cyclades, the Turkish coast, thousands likely die in the tsunamis. More die in the subsequent famines. The eruption creates a marker horizon for Bronze Age archaeology. Any site with Santorini tephra dates to post 1550 BC. The caldera that remains is 15 kilometers across. 3 islands, Ringet, Thera, Therasia, Aspernici. A new volcano, Nea Kameni, grows in the center. It erupted as recently as 1950. The eruption may have inspired the Atlantis legend. Plato writes about Atlantis around 360 BC, 800 years later. He describes a powerful island civilization destroyed in a day and a night. Thera fits. But Plato says Atlantis was in the Atlantic beyond the Pillars of Hercules, and his timeline doesn't match. Most scholars think Atlantis is fiction, but if there's a kernel of oral history behind it, Santorini is the candidate. The eruption definitely influenced Egyptian records. The Ahmose Tempest Stele, dated to Ahmose's reign around 1550 BC, describes storms, darkness, and destruction consistent with volcanic effects. The dating overlap is close. Santorini ash has been claimed in Nile Delta cores, but those finds are disputed. The eruption is remembered in the region. The scale ensures that these 7 eruptions, Tambora, 1 million dead from famine, Pele, 30,000 in minutes, Ruiz, 25,000 in Al-Lahar, Krakatoa, 36,000 in tsunamis, Unzen, 15,000 in a mega tsunami, Laki, 8,000 in Iceland, tens of thousands globally from cold, Santorini, unknown but enough to end a civilization. They span 3 continents, 4 centuries if you include Tambora to Ruiz. Each one rewrites the landscape. Each one proves that the deadliest volcanic threat isn't always the lava. It's the secondary effects, the wave, the mud, the ash cloud that blocks the sun, the crops that don't grow, the famine that follows. Volcanologists rank eruptions by magnitude, by volume of ejecta, by volcanic explosivity index, but the death toll doesn't scale linearly with power. Santorini is a 7, Krakatoa is a 6, but Krakatoa killed more people because of where it happened. Dense coastlines, no warning system, the wrong time of day. Tambora is a 7. It killed fewer directly than Krakatoa, but way more indirectly because the cooling was global and the famines were widespread. Ruiz is a 3, tiny eruption, but the Lahar path went straight through a town at night during a storm. Location and timing matter more than size. The pattern repeats. In 1991, Mount Pinatubo in the Philippines erupts, VEI-6. It evacuates 75,000 people before the main blast. 350 die, mostly from roof collapses under ash weight. The evacuation works. Compare that to Ruiz in 1985. The warning was there, but the execution failed. In 2018, Anak Krakatau collapses and kills 437 in a tsunami. Same spot as 1883. The mechanism was predicted. But the tsunami warning system didn't trigger fast enough because the landslide didn't produce strong seismic waves. The volcano didn't shake the ground hard enough to set off alarms. By the time the wave was detected, it was already hitting the coast. The lesson from these 7 is that eruptions don't need to be big to be deadly. They need to be in the wrong place, near a coast, near a glacier, near a population that doesn't have time to run, and they need to produce the secondary killers, lahars, tsunamis, climate disruption. Pele taught us about pyroclastic flows. Ruiz taught us about glacial melt lahars. Krakatoa and Yunzin taught us about landslide tsunamis. Laki taught us that flood basalts can kill globally through atmospheric effects. Santorini taught us that even Bronze Age eruptions can collapse civilizations. Tambora taught us that volcanic winter is real, and that famine is the worst killer. The monitoring is better now. Seismometers on every active peak, satellite observation, gas sensors, tilt meters, ash models. Tsunami boys, but the people are still there. Millions live on the flanks of Vesuvius, 500,000 in the Ruiz Lahar zones, 120,000 on the slopes of Merapi in Indonesia, which erupted in 2010, killing 353. The risk grows because the population grows. The systems work when they have time, when the warning is hours or days. But some eruptions give minutes. Pele gave 60 seconds from the blast to the city. Ruiz gave 2 hours from eruption to impact, but the message didn't get through. Even with modern tech, if the communications fail or the officials hesitate, the death toll climbs. The geology is unforgiving. These 7 mountains didn't care about human infrastructure. They didn't care about governments or warning systems or evacuation plans. They erupted when the magma pressure exceeded the strength of the rock. The rest is consequences. Krakatoa ejected cubic kilometers of rock because the chamber was full and the vents were blocked. The explosion vented the pressure. The collapse followed because the unsupported chamber walls fell in. Unzen slid because an earthquake shook loose a 4,000-year-old dome. Laki opened because a fissure system rifted under tectonic stress. Tambora blew because dacitic magma, rich in silica and gas, reached critical overpressure. Pele exploded laterally because a dome collapsed and released a pressurized blast. Ruiz melted ice because hot tephra hit cold glaciers. Santorini caldera collapsed because the magma chamber emptied during a sustained Plinian eruption and the roof fell in. Every mechanism is different. Every death toll is unique, but the pattern is the same. Pressure builds, the earth breaks, people die, and it will happen again. Yellowstone, Campi Flegrei, Taupo, Katla, Anikchak, Long Valley. These are the calderas that haven't blown in our recorded history, but will someday. Yellowstone last erupted 640,000 years ago, VEI 8. It ejected 1,000 cubic kilometers. If it erupts at that scale again, North America goes dark under ash. Global temperatures drop for years. Crop failures worldwide. The death toll wouldn't be thousands. It would be millions, maybe billions. Campi Flegrei sits under Naples. 400,000 people in the caldera. Last major eruption, 39,000 years ago. It's showing signs of unrest now. Ground uplift, increased seismicity. If it goes, southern Italy evacuates or dies. Taupo in New Zealand. VEI 8, eruption 1,800 years ago. The next one would devastate the North Island. These aren't distant threats. They're geologic certainties. The question is when, not if. The 7 eruptions in this script killed somewhere between 200,000 and over 1 million people, depending on how you count Tambora's global famine toll. That's more than most wars in the same period. The eruptions didn't need armies or strategy. They just needed the right conditions. A full magma chamber, a weak flank, a coastal population, a locked dome, a glacier, a fissure under stress. When the conditions align, the mountain moves, and when the mountain moves, people die. No amount of monitoring changes the fundamental physics. You can evacuate, you can prepare, you can mitigate, but you can't stop it. The pressure will vent. The only question is whether you're in the way. The 7 mountains are quiet now. Tambora hasn't erupted since 1880 Onigiri. Pele last erupted in 1932. Minor activity. Ruiz is monitored constantly, active but stable. Krakatoa is rebuilding as Anak Krakatau, erupting every few years. Unzen erupted 1990 to 95, then went dormant. Laki is part of a fissure system that could reactivate any time under Iceland's volcanic zone. Santorini has a resurgent dome, Nia Kameni, that last erupted 1950. None of them are extinct. Dormant doesn't mean dead. It means waiting. And waiting doesn't mean safe. It means the pressure is building again, slowly, invisibly. Until one day, the rock breaks. The gas vents, the ash rises, and we count the bodies again. These 7 eruptions are in the past. The next 7 are loading. And somewhere, right now, a seismometer is picking up a tremor that nobody is paying attention to. A gas reading is climbing. A dome is swelling. And the people who live on the flanks think it's normal background noise. just the mountain breathing, until it stops breathing and starts screaming. And then we add another name to the list, another date, another death toll, another reminder that we live on a planet that doesn't care if we survive. It just erupts, and we either run or we become the layer in the ash deposit that archaeologists dig up 1,000 years later, wondering how we didn't see it coming. Because the truth is, we do see it coming. We have the data, we have the sensors, we have the evacuation plans. What we don't have is the ability to make people leave their homes when the mountain looks calm. To make governments spend money on a disaster that might not happen this year. To convince someone that the rumble they feel is the sound of their death unless they move now. Tambora rumbled for 3 years. People stayed. Peli smoked for weeks. People stayed. Ruiz warned for a year. People stayed. Because leaving is hard, and believing is harder. And by the time the cloud or the wave or the mud is visible, it's too late. The window closes. The eruption wins. And the survivors tell the story so the next generation knows, but the next generation forgets. And the cycle repeats. These 7 eruptions killed hundreds of thousands. The next 7 will kill more, because there are more people, in more places, on more volcanoes, and the Earth doesn't care. It just builds pressure and waits until the moment when the rock breaks and everything changes again.